So students, we got a formula for epsilon 0 from Coulomb's law of electrostatics. Okay student? So the dimensions of epsilon 0 will be equal to, what is this? This is charge. So we can write this as q square divided by 4 pi is a number students, so it is dimensionless. We can write the dimensions of L into dimension of R square. So what is Q student? That is IT, because current is the time rate of flow of electric charge or electric current at a particular point is defined as the quantity of electric charge passing through that point in unit time, that is in 1 second. So Q is equal to IT student. So we will write it IT to the power 2 divided by what is the dimensional formula for force, that is mLT minus 2, and for R square we will write L square, and this is A to the power 2 T to the power 2 divided by N L3 T to the power minus 2. Okay students, then this will become M to the power minus 1 L to the power minus 3 T to the power 4 and A to the power 2. Okay students, this is the dimensional formula epsilon. Where is it? Minus 1 minus 3 4 2 minus 1 minus 3 4 2. So option B is correct for epsilon 0. Now let us find out the formula for student magnetic permeability mu 0. We obtained a formula for epsilon 0 from Coulomb's law of electrostatics. Where shall we find the formula from mu 0, the magnetic permeability students? We will get the formula for mu 0 from Biot-Savart law. Biot-Savart's law. This law states, student, if this is a current carrying conductor, I current is flowing through this conductor, if this is a line element dl, and if this is a point r here, this is r and this angle is theta, this point P is specified by the coordinates r and theta students, then the magnetic induction vector dB, also called the magnetic field at point P, is given by Biot-Savart law, that is dB is equal to mu 0 by 4 pi I dl cross r by r cube. This is a vector, this is a cross product of two vectors dl and r student. Okay, this is dl, this is dl and this is r. Okay student, this is r. So the magnitude of dB will be equal to mu 0 by 4 pi I, this is dl r sin theta by r cube. Okay student, and this r will cancel this r cube to r square. So this becomes, we can obtain a formula for mu 0 from this expression students. Mu 0 will be equal to 4 pi r square dB divided by I dl sin theta. Okay student, you see, from that formula we obtain this formula. Then students, let us find out the dimensional formula for mu 0 from this formula we obtained now. What will be the dimensions of mu 0 then student? Mu 0 will be equal to dimensions of 4 pi. What is dimension of 4 pi? 4 pi is a constant, it is a number, so it is dimensionless. Similarly, sin theta is a trigonometric ratio, it is the ratio of two lengths, so it is also dimensionless. Student, we will ignore these two terms. Then mu 0 will have the dimensions of r square into dB. dB has the same dimensions as B, magnetic induction vector, and this is divided by I current and dl. Okay student, then what is B student? What is the formula for B? B, the force in an electric field is given by BIL, where B is the magnetic field, I is the current, and L is the length of the current carrying conductor. This is the formula. From this formula, we obtain a formula for B, that is F by IL. We will put it here. Okay, student. Then this becomes R square is L square, and B, what is B? B is F by I L, and this was ideal, means I and L. Okay, student. Then this is L square MLT minus 2 is the dimensional formula of force. This is current, so this is S square, and this is L, this becomes L square cancels out, student, and the dimensional formula of mu 0 comes out to be MLT minus 2, a to the power minus 2. Where is it? MLT minus 2, a to the power minus 2. So option C is correct. So students, option B and C are correct for epsilon 0 and mu 0.